Good morning, student. We already see up to yesterday the new chapter, that is the chemical kinetics. Into that, we had seen that about the average rate and about the instantaneous rate. Now we are learning today the rate law. Now, what is this rate law? This is not the statement. This is not as that of the statement, but this is the only the equation. Rate law is only the equation from general chemical reaction or any chemical reaction. We can write the rate law. Now this is very important, and this rate law is given in the concentration terms raised by the suitable powers. Now in this rate law, the general reaction we have to take first. Now consider the general reaction. AA plus BB gives CC plus DD. Here capital A and capital B are the reactants, and capital C and capital D are the products. And these small letters A and B are these are the number of moles of the reactants A and B respectively. And small letter C and D, these are also the number of moles of the products C and D. Then how the rate law is given? Now we know that rate of the reaction is directly proportional to the concentrations of reactants. So the rate of the reaction is given as rate of the reaction is directly proportional to, now this square bracket means concentration. Concentration of A raised to X into concentration of B raised to Y. Now it is given as rate of the reaction is equal to K into concentration of X, K into concentration of A raised to X and into concentration of B raised to Y. Now where this K is called as the proportionality constant, or it is also called as the rate constant. Now this rate constant K is independent on the concentrations of the reactant, but it varies with the temperature. That means it depends on temperature but independent on the concentrations. And these powers X and Y, these are also the experimentally determined quantities. As these powers X and Y are experimentally determined, the rate law is also experimentally determined, and it is given from the observations of the reaction. Now these powers X and Y of the concentration terms A and B respectively are called as the orders. They are called as orders. And these X and Y may be simple whole number, they may be fraction, or they may be zero. They may be negative quantities also. These powers X and Y. As the reaction is carried out, how the concentration of A and B changes, on that the value of X and Y depends. Now this rate law is also the experimentally determined law. Now suppose in this equation X, this equation, now our equation, this is the X equation. Now in X equation, if we put in the X equation, if we put X is equal to 1 and Y is equal to also 1, then how this rate law becomes? Then the rate law becomes rate is equal to K into concentration of A into concentration of B. Now here X and Y are 1, 1. That means the rate of the reaction is linearly depends on the concentration of A or concentration of B. If we double the concentration of A or concentration of B, the rate also doubled. Now if X is equal to 2 and Y is equal to 1, now put X is equal to 2 and Y is equal to 1 in this equation. Then how the rate law is given as? This X equation becomes rate is equal to K into concentration of A bracket square into concentration of B. Now this is the rate law. If the X is equal to 0, and what is the rate law then? Suppose X is equal to 0. Then rate is given as here, rate is equal to only K into concentration of B raised to Y. Because we know that the concentration terms of A is raised by the quantity 0, X is equal to 0, that becomes 1. Therefore, rate law becomes rate is equal to K into concentration of B raised to Y. In this way, the rate law changes. Now, let us see the problem 6.2 on the rate law equation. That means rate law. Now, the problem is in this way. Write the rate law for the reaction. This reaction is given. A plus B gives products. And we have to write the rate law of that reaction from this data. Now this data is given. Now in that data we have given the initial concentrations of A and B and the initial rate law. Initial rate is also given in moles per decimeter cube per second. All these are given. In the data there are three different values of concentration of A, concentration of B and initial rate are given. Now we have to write down the rate law in the language such that rate is equal to concentration of A raised to X, concentration of B raised to Y in this way. Rate is equal to K into concentration of A raised to X into concentration of B raised to Y. In that language of the rate law, we have to write the rate law for this reaction from this data. Now, let us see our rate, that means we have to find out the values of the powers X and Y. Now, we know that the rate law generally given as rate law is equal to K into concentration of A raised to X into concentration of B raised to Y. Now, we have to find out the X and Y. Now, let us first from the these two initial concentration 1 and 2 find out X or Y first. Now let us see which we have to find first. Now this is the first. Now here the rate is 4.0 into 10 raised to minus 5. So I write in the first equation of rate law, rate is equal to 4 into 10 raised to minus 5 is equal to, what is the concentration of A in the first data? 0.4. So I write here 0.4 raised to X. And what is the concentration of B in the first data? Now 0.2. So 0.2 raised to Y. Now this it becomes our first rate law equation. From the data given, the second rate law equation becomes in this way. Now here initial rate is 6.0 into 10 raised to minus 5. So I write here equation 2 as 6 into 10 raised to minus 5 is equal to the initial concentration of A is 0.6. So I write here 0.6 raised to X and initial concentration of B is 0.2. So 0.2 raised to Y. Now this is the second rate law from the data. Now only divide equation these two by 1. Then we will obtain the one of the power X or Y. Now how it is? See, divide equation 2 by 1. So I divide here the equation 2 by 1. Now this 6 into 10 raised to minus 5 get divided by 4 into 10 raised to minus 5 is equal to 0.6 raised to X into 0.2 raised to Y divided by 0.4 raised to X into 0.2 raised to Y. Now see here in both these equation 1 and 2, this 0.2 raised to Y, 0.2 raised to Y, that means concentration of B are similar and there if that get cancelled here. Now what is remaining? Now this quantity. Now 10 raised to minus 5, 10 raised to minus 5 also get cancelled. only 6 divided by 4, that comes 1.5. 6 divided by 4. Here what? Which are remaining? 0.6 raised to x and 0.4 raised to y. As their powers are similar, they only divided and they have given the power x. Now here also 0.6 divided by 0.4 becomes 1.5 and raised by the power x. Now see, both these are similar. 1.5 here, 1.5. So the powers are also similar. So x is equal to 1. Now let us calculate now x is equal to 1 we obtain. Now divide equation these 3 rate log from this data, the equation 3 becomes in this way. Now see, this is the equation 3. What is the rate? Initial rate is equal to 3.2 into 10 raised to minus 4 is equal to initial concentration is 0.8 raised to x and initial concentration of B is equal to 0.4 raised to y. And the first equation is as it is, this first equation. Now divide this third equation by equation 1 to obtain the value of y. Now after dividing this 3.2 into 10 raised to minus 4 divided by 4 into 10 raised to minus 5 is equal to 0.8 raised to x. The value of x is 1. So I write here 1, but 1 is not shown. Therefore only 0.8 and 0.4 raised to y. This again divided by 0.4 raised to x. Here x is equal to 1, therefore 0.4 is it, and 0.2 raised to y. Then this becomes, suppose this is power of 10 is minus 4 here. This is 3.2 into 10 raised to minus 4. We can write 32 into 10 raised to minus 5. Why that? Because we have to cancel 10 raised to 5, 10 raised to 5 here. Again, this quantity 0.8 divided by 0.4 becomes 2. And this 0.4 divided by 0.2 bracket raised to y. In this way the equation becomes. Now here on dividing this, we obtain the value 8. Now this is the 32 divided by 4 is equal to 8. And this 2 is multiplied here, it gets divided here. And here only remain this 0.4 divided by 0.2, that is equal to 2 and raised to y here. Therefore this becomes 4 is equal to 2 raised to y. That 4 is the square of 2. So 2 square is equal to 2 raised to y. Now here both these two are equal, therefore y is equal to 2. Now both powers value we have obtained, x is equal to 1 and y is equal to 2. Then our rate law becomes rate is equal to K into concentration of A. Here x is equal to 1, so not given here, and concentration of B raised to 2. Now this is the rate law for this reaction. In this way we can solve the problem.